Well, hello everyone. This is KP the Math G. Um, Nice evening tonight, and pretty cold, but we're in the warmth of this nice home here, and we're going to do a calculus problem. I'm excited, aren't you? 2000. That's the AB test, AP Calculus AB 2000 test, free response question number 2. The question goes like this: two runners, A and B, run on a straight track for on a time interval from 0 to 10 seconds. Time T is between 0 and 10, including 0 and 10 seconds. The velocity of runner B, and I guess I should say of runner B, of runner, B is given by B at T is equal to 24T over 2T plus 3. Runner A has a velocity of this green line, this green graph here, and so we have two different things. One, runner A there's a graph for runner A, in other words, and there is an equation for runner B. Both of these are velocity equations, or deal with velocity, if you will. All right. Now, we are dealing with part C. Part C says find the total distance of runner A and runner B on the interval where T is between 0 and 10. Now, the question is, somebody may be saying, well, what do you do? Do you do the derivative, or do you do the definite interval? Most of the time, when you see when you see on the interval, you're probably going to be doing a definite interval. But now, let's just review just to make sure we understand this. When we're talking about the total distance now, and this is in terms of velocity, so really and truly, if we did this, we would do an interval. Let's just say from A to B, let's put it in general terms, from A to B, B at T, alright, is equal to, now this is going to be, or dt rather, this is going to be equal to, well actually if you did this right here, total distance. Alright, when you take the definite integral of velocity, you get distance. Okay? Just keep that in mind. If you start off with distance, you take the derivative to get the velocity, then you take the derivative to get the acceleration. If you're at acceleration, you take the antiderivative or the definite integral to get to velocity, and then you take the definite integral of velocity to get to distance. Think about that. So we're talking about total distance. And remember, I always said that when you have a rate and you want distance, like in terms of meters, in this case it is meters, or feet, or whatever, or miles, then you're going to take an antiderivative every single time. So kind of keep that in mind right there. Alright, so let's deal with the runner A. I just kind of want you to be familiar with, I mean, you probably already know this, but you may need a review on it. You might have needed a review on that. So sometimes, I know when I talk to some of my students, they always ask me, when you do a derivative, when you do a definite integral. Well, and this is what I talk about. anytime you take an antiderivative, a definite integral of rate, you're going to get something like amount. Okay? Well, in this case, amount is total distance, isn't it? In meters. Alright. Now, let's think about this. When you're talking about a graph here, and you look at, you're wanting total distance of that, think of the word area. I want to find the area underneath this. I want this entire area. I want this all here. Now, there's two ways we could do this. One way we could do this is divide this up into a triangle and then take the rest of this as a rectangle and figure out that way. Either way, you're going to get the total area. Now, if we do it this way, well, the other way is by the trapezoid method. This figure here, including the dotted line, is a trapezoid. Okay? So I'm going to do it first by the triangular method. Let's see, we're going to erase that there. That was from a problem B, I think it was, or even A and B for that matter. And we're going to come straight down right here to 3. This is at 310, so we're going to go straight down where X is 3. Alright, right there. Alright, we know that X is 3 and Y, well, from 0 to 10 is 10. Alright, this is the base. Well, we could say the base. The base is equal to 3. The height is equal to 10. But now it's not just 3 times 10. Remember, on a triangle, it's 3 times 10 divided by 2. So it's 30, 3 times 10 divided by 2. So this is 30 divided by 2, which is 15. Now that would be in meters. Okay? Now the rest of this is a rectangle. What are the dimensions of this rectangle, if you will? What are the dimensions of this? I'm trying to erase all this red off here. That's okay. 10 by, alright, this is 3 here. The whole thing is 10. So 10 minus this 3 is 7. So 10 by 7 here. 10 times 7 is 70. Alright, so 70 meters plus 15 meters is 85 meters. Alright, right there, 85 meters. Okay, that's one way to do it. Another way is to do it, find the area of this trapezoid, which we're going to do. So let me find some eraser stuff here. Okay, right here. Yeah, I got this right here. I got a regular eraser, but it's not doing well for me right now, so I'm just having to use this kind of stuff here. Alright, we're going to do it by the trapezoid. We should get, now remember our answer is 85 meters, right? I'm going to erase this because I don't want the triangle anymore. And matter of fact, I'm just going to erase all this. I'm going to work inside of this area right here. Alright, we are talking about runner A. Alright, and we want the total distance for runner A. And anytime you have velocity written over here, you want total distance. You're just looking for the area. That's what you're doing. Okay? Kind of keep that in mind, and that'll save you some time. If you practice this, you'll get really good. Now, what's the area of a trapezoid? You have a base, parallel bases. We're going to add up the bases. So base 1, So area of a trapezoid is base 1 plus base 2 times the height divided by 2. And we better get 85 meters, right? Right, base 1, we'll call this base 1 down here, that's 10. So 10 plus, alright, 10 minus 3 is 7. This is 7 right here. So 10 plus 7. The height itself is 10. And then we're going to divide by 2. There it is. And to me, I mean, either way, you have one thing instead of one big area instead of two areas that you can do here. Alright, so let's see. 17 times 10 over 2. Yeah, okay, so 170 over 2 is what? 8 times 2 is 8 times 2 is 16. Carry 1 over, and 10 divided by 2 is 5. So 85 meters. Again, same thing, and that's what we should get. You're always dealing with area. If you have velocity, that area really means not just area, it means distance. So it's going to be in meters, okay? Alright, so that is what you're doing there. If you multiply velocity times time, that's what you're really doing. Meters per second times the second over 1, seconds divide out, and you're just down to meters. So when you multiply like that, that's what you're getting, okay? Alright, now this one is a different thing altogether. It's actually pretty easy to find. If you use the calculator, it's very easy to find this one here. I'm going to do it the long way, but I'm going to say this. Don't do that if you're taking an exam. You have your calculator, you have that integrand symbol like this, use it. Okay? Use that. Alright, now let's see, this is 24t over 2t plus 3. I'm going to do this on the other side. It's going to take a little room here. 24t over 2t plus 3. 24t over 2t plus 3. That's the velocity equation. We are going from 0 to 10 as we did a while ago, and this is in dt. Okay, just kind of keep that in mind there. I'm going to take this is 24. I've got so much stuff here, and stuff keeps getting in the way here. I got to pick that up. I'll do it later. I've got this 24t in the numerator. I can put that on the outside like that. Okay, that's what I want to do. Alright, so that's what I'm going to do there. Alright, so let's do that. So let's put that on the outside. A little bit of cleaning up a little bit, you know what I'm saying? So I'm going to put the 24 right out here. Alright, and that's going to leave us with t over 2t plus 3 dt. And for right now, I want to leave that empty. I'm going to show you why in just a moment. Well, let's go ahead. 0 to 10. Okay, 24. I don't know why I put 25 there. Probably shouting through the camera here. 24 KP the Math G. Alright, yes, that's right. Now, I see a problem here. I wish this were squared, and that would make this a whole lot easier. But it's not squared, so here's what we got to do. I did a video on this a while back, but I'll show you how to integrate this again. Now, I'm doing it by hand. You can quickly do this, very quickly do this on your calculator. If you do this right here, even leaving it just like this, yeah, you'll get your answer very, very quickly. All right. So I'm going to do it by hand, and this may be for those who are just taking calculus, okay, and you want to learn how to do this. Now remember, let t be equal to this bottom. I want to leave it, I choose the bottom, 2t. You don't want, let u rather, not t. I've already got t. All right, 2t plus 3. Okay, excuse me. All right, now let's, before we got to do du over here. Okay, so du is equal to 2. The derivative of the left side is du. The derivative of the right side is 2 dt. So really I want to multiply by half. Alright, so I'm going to r divide by 2. We can do either one. I'll divide by 2 since I'm out of space over here. So du over 2, or just 1/2 du, is equal to dt. I want to kind of keep that in mind. Don't forget that, because I did one time on a video, and man alive, I just okay, I had to explain why that wasn't true. Now I also, while I have u is equal to this, and I've already did my du, matter of fact, if I want to, I can go ahead and put that 1/2 right here and not worry about that. I can multiply that by 1/2 and not have to worry about the 1/2 later on. Okay, so there we go. Alright, now we're going to, let's leave this off for right now. I'm going to show you what to do here. First of all, before we go any further here and solve for t, I do want to solve for t right here, but I want my limits of integration. I'm going to leave this in terms of u, so I can just do my limits, change that. So there is a way you can do that. So u is equal to, well, our limits are going to be 2 times, now the top, alright, 2 times 10 plus 3, that's 20 plus 3, which is 23. So instead of 10, I'm going to put 23. I'm using this now to change this right here. I'm going to put everything in terms of u. Alright, then also on the bottom, so 2 times 0 plus 3 is just 0 plus 3, which is just 3. So this is 23, and this is 3. So I'm going to do that right there. Okay. I hope you understand that. So whatever you let u be, just simply plug these numbers in to this right here, to this t right here. So 2 times 10, 20. 20 plus 3 is 23. 0, 0. 2 times 0, 0. 0 plus 3 is 3. So that's because I'm going to keep it in terms of u. Okay. Alright. Let me erase this, because I'm going to need a lot of room here. Alright, bear with me. I appreciate everyone here. Okay. Alright, now let's use a different color. I think maybe sometimes a little different change is better. Alright, now I'm going to solve for t right here. Alright, so let's see. If I subtract 3 on both sides, I've got u minus 3 is equal to 2t. So I want t by itself. I don't want 2t, I want t. So I'm going to divide by 2. Alright. And actually the same thing, what I could do is, instead of dividing by 2, well, it doesn't matter. We can divide by 2. Alright, so t is equal to u minus 3 over 2. And sometimes you can make this 1/2 like this, so you could make this a 1/2 u minus 3 is equal to t. And here again I got another 1/2 that I can throw over there like that. So I can put that over there and just deal with just this part right here being equal to t, right? So let's get that 1/2 out of there. So I already have 1/2 times 24 times another 1/2. Alright, and then from 3 to 23. Alright, so I guess maybe I could have moved it up here, but I'm just kind of showing you each step that I'm taking one step at a time. Alright, so that right there, I don't need to worry about that 1/2 now. So now what do I have here? Okay, so I've got u, t is equal to, already got the 1/2 over here, so really t is just u minus 3, u minus 3, alright, and then I'll let 2t plus 3 be equal to u, alright, so u like that du. Alright, I'm not satisfied with the way this is, so here's what I'm going to do right here. There is a rule that says that a minus b over c is a over c minus b over c. Alright, I'm going to rewrite it that way. Alright, so let's do that. I don't like that u in the denominator. Okay, so let's rewrite all of this. Let's see, let's get this front number here. 1/2 times 1/2 is 1/4. Alright, so 1/4 times 24 is 24 over 4, which is 6. Alright, so this number now is 6. We are still integrating from 3 to 23. Alright. Alright, let's see. Let's take this u minus 3 over u like this. U over u minus 3 over u. 3 over u. Alright, u over u is 1. So 1 minus 3 over u. Now I do like that. I do like that. You see, if I'm going to use everything or place everything in terms of u, I've got to change these numbers. If I'm going to put these substitutions back in, I can leave it from 0 to 10 like that. I don't know how you learned that, but this is one good way to do it. It does make life a little simpler. This is not the easiest of problems to integrate, but it's still doable, okay, by hand. Alright, so now let's do this. I've got 6 right here. Alright, 6 times the antiderivative of 1 is just u. Now, if I were to take 3 over u du, do you remember what this is? Okay, see, this is the same thing as saying ln. If that's u to the 1, that is ln, isn't it? So this is actually minus. If I were to put the 3 on the outside and make this 1 over u, this is ln. So 3 times ln, like that, of u. Alright, so minus ln of u. Okay, and sometimes we put absolute value bars, but we're not going to need that because our numbers here are both positive. So if we did have a negative number, we would need to have absolute value bars here. Alright, so now we're going from 3 to 23. Alright, and I'm going to need more area here, some more space up here. I hope you already have this, so let me erase this and we'll put it up here. Again, please bear with me. I appreciate everyone. Okay. I know this is a long, lengthy problem and probably could have been done on a separate video, but I wanted to do both of these together. But anyway, here we go. Now this is, I can probably, let's do it up here. 6, here we go, 6 times u, which is 23, I'm plugging 23 in first, minus ln of 23, minus sign. Now don't forget parentheses here. You have more than one term, you need a parentheses here. Now I'm going to plug in 3. Alright, 3 minus ln of 3. Close it up. Now that's it right there. Okay. If I multiply this all out, okay, and it does work out, I will get a grand total of 83.336. So, I mean, I can do it on my calculator and show you that that does work. Let's see, I'll multiply by 6 last, so 23 minus ln of 23. Alright, let's see, minus 3, and minus a negative is plus, so plus ln 3, where is it, ln 3, alright, and then we'll hit equals there, and then times 6, and let's see, got too much there. Let's see, it should be something smaller than that. I did everything right. I know I did it on another sheet of paper and got it correct. Let's see here. It's 23. Okay. Alright, let's see. When you know that I would do this and it would not work out. Let's see, 23 minus ln of 23. I got a number bigger than that. Okay, so minus 3 minus ln 3. Okay, that equals, and that should be, that's wrong too. I'll try it one more time. I know what I did wrong on that one. Minus ln, I do apologize for this, 23. Okay, so now minus 3, and now plus ln of 3. Alright. Okay, so times 6. Too much. I don't know what I did incorrectly there. Let's see. And I had this on another sheet of paper, but I will assure you that that is the correct way to do this right here. The answer is, I'm getting too much. I don't know why I am. 83.336 meters. Okay, and I don't know why I have this. I know it should be 6 here. I did that. I did it just a while ago. Hold on just a second. Let me see if I can. Give me a second here, and I'll see if I can figure out where I put this problem at. Yeah, I did it here, and I got the correct answer, and it is 23 minus, oh, I see where I left off. This is a 3 here. Alright, and that is so minus 3 times that. Yeah, I left that 3 off of there. That makes a difference. Okay, so let's try it again. Oh, I'm so sorry, I left that 3 off of there. Okay, well, we'll try it again. I think we'll get it this time. Alright, so let's see, this should be, alright, minus 3 here. Yeah, I'm thinking, yeah, that's right. And then 3 here. Let's try it again. Okay, now one more time, and if I don't get it this time, I will do another video and I will straighten this out. That 3 is up here. I should have put it in front of here, and I didn't do that. So let's try it again. 23 minus 3 ln of 23 close parentheses minus 3 plus 3 ln of 3 close parentheses enter times 6 enter. It works, and I got it. There it is. I don't know if you can see that or not, but there it is right there. I got it. Oh my. Well, if you leave out a number, I think if you did this right here, now again, if you just put this in here like so and hit the